Okay, I'm going to give this a try. What I've done is my kitchen HQ cooktop. I took out I have a spare one, and I took out the components, traced the circuit. This is a full wave bridge. It goes 4 leads there. Here's the IGBT, etc., etc. So I took out the necessary components and made my own board without all the features and stuff. Peripheral. And I showed this last video, my circuit here, and I've made a few changes. Main change is I put in a SiC MOSFET instead of the IGBT, and it's a 120Mi045 MOSFET. It's rated at like 54 amps and 1200 volts. Has a lot less internal resistance when it's closed than an IGBT. So I have that here. And what I also did is I put a Zener diode, 15 volt Zener diode, from the source to the gate, with a stripe facing towards the gate. I also put a 10K resistor here, which is maybe not necessary, but I like to have it because it makes sure that it's going to turn off. So a 10K resistor also from the source to the gate. I have a 4422 instead of a 4421 like I had before. This is the gate driver chip. I kind of flattened the, instead of using a socket. What's that little bit of junk there? So anyways, it's fairly easy. You have the positive side, there's a little indentation here. So you hook those up. And the negative side, you hook those up. This is, you put these two together, the two middle ones, and that goes to the gate of the MOSFET. And I originally had an RF filter. I was advised by Oli of VV Gray Group to not do that, because it might cause some inductance and ringing. So I just have a 20 ohm resistor right here. And that's supposed to stifle any ringing to the gate. So here's the output from the chip. It has the signal coming in. It's going to be set at 24 kilohertz. And this is the green wire is what receives the signal. And that comes out of this thing. And you can set frequency and duty cycle with this. So this is powered by a 12 volt battery over here, and also the positive and then the negative of the chip here, gate driver chip, is also powered by the same 12 volt power source. I have the source lead on the right of the MOSFET also goes to the ground here. A lot of times you hook this up and you forget to put this there and you don't know why it doesn't work. So it's not too complicated. Now, let's start from the output and work our way backwards. Here's the output to the coil, the primary coil under here. It comes with the cooktop. Nice looking one. This is what's going to be induced, which is going to power all these lights. This, the bifilar stack of coils. So here's what comes in, goes out. This is the output, this and this. The blue wire here, this is output number 2, I call it. That goes right to the drain of the MOSFET. See that? Here's the drain, hops over, goes right there, directly to it. The drain goes to one side direct, so there's that. Also, this .33 resonator cap, whatever you want to call it, it goes one side to here and one side to here to the output. That's shown in the drawing here. Now, gets a little more complicated. The source of the MOSFET goes to the ground side of the full wave bridge rectifier and one side of the one of these 10 UF caps. C3's 10 UF 275 volt AC MKP times 2. I looked up what MKP means. It's kind of a safety sort of cap where it's not going to short circuit or do anything. It's going to like kind of just pop a hole in itself or something. That's what the MKP is about. So it's a 275 volt cap right here between the negative of the full wave bridge, which is connected to the source, and it jumps over to the positive. See, the positive of the full wave bridge runs through this choke, I guess you'd call it, toroidal choke, and it connects to the other side here, and then that goes to the other output. And I have that represented here by this red wire. Here's that choke. Comes out from the choke, attaches to this side of the cap, comes out, and goes to the other side of the output. Okay, the other side of the cap, which is the ground, the negative ground you could call it. One side of the cap goes to the positive, to the output, so that's the red wire to the output. The other side goes to the source, right here. This is the pin on the far right side of the MOSFET. It's kind of the ground, common ground pin. And that, so there's that 10 UF cap, goes to there. And it also goes to the negative side of the full wave bridge rectifier in DC, the DC side. The DC positive side goes into the toroidal choke thing. Okay, so this is all correct so far, according to what I mapped out from what I pulled out of the kitchen HQ cooktop. Here again is the MOSFET number 120MI45. Got it I could get them for $12 on eBay. Now, it's a 35 amp, 1 kilovolt, 1000 volt full wave bridge rectifier. That's more heavy duty than what's in the cooktop. So let's go back here and start at the beginning. Here's 120 volts, 60 hertz from the grid. You could have a pure sine wave inverter too if you want. So L1 goes to the fuse. Here it is, the fuse. I just soldered it. And then there's this small little cap, C1, 270 PF ceramic disc capacitor goes across. C1, C2 is this one, and it has one side of the AC over here and one side of the AC over here. See, I have the green stripes on the right side. And then this kind of I guess it'd be an RF filter, something. And these wires are not connected to these wires, so the AC runs through these. I guess does an RF filter on this side of the toroid, and it runs on this side of the toroid and goes out. So now you have this going into the AC side of the full wave bridge rectifier. So I think that's about it. I'm using a 4422 instead of a 4421 now. No RF filter, just a 20 ohm resistor right here going to the gate. Again, the resonator cap is 0.33 UF 1200 volt DC, and that goes right across the output. What's interesting is on this spiral flat coil thing, these are all 0.33 also. 0.33 UF. On this one, the final output, which is this, that goes into the lights, there's actually two of these in series, while the rest are dedicated to a layer or two layers of the flat coil stacked up. The first one is interesting the way it hooks up, but I won't go into that right now. This is Willie Filsinger of Canada, his invention, based on kind of Tesla's bifilar series 80 invention he did about 1897. He called it his greatest discovery. So when you have bifilar coils right next to each other, wound, and then hook them up series 80, it creates all this capacitance in between the winds. But I won't go there. Okay, so what I'm going to do, I don't know if this is going to work. I would say it's not going to work because I've tried it. I've tried this a few times already, and IGBT wasn't working. I don't know. this might work. So let's have a little drama here and see what happens. First, I'm going to plug in the battery. Now I've turned on this pulse width modulator frequency signal generator, more or less. And I have it at 24.1 kilohertz and 50% duty cycle. Isn't that nice? I can change the frequency, I can change the duty cycle. So this is what it's supposed to operate on, and when I looked on the scope, it looked like 50% duty cycle, so that's what I'm going for. Now, I'm just going to plug this in right now, see what happens. Ready for a fuse to blow. What happens? Yep, fuse blew. Okay, well, you saw it. So this is about my fourth or fifth attempt to get this to work. If anybody has any ideas why it doesn't work, somebody told me in my last video, do not even try it. It's dangerous. Somebody else says the military's weaponized these. I don't know. So if anybody sees an obvious problem, let me know. I've always thought this, the way the MOSFET hooks up, just doesn't look right to me. Seems like you'd want to have both fill up the coil from the full wave bridge rectifier directly. Anyways, so there's a 18-minute video. Thanks for watching.